Hello, everyone, and welcome to Agentic AI The Awakening, a deep dive into the next evolution of artificial intelligence. I'm your host, Korea Prime, and over the course of this series, we'll explore how AI is transforming from passive tools into proactive teammates. Today, in Topic 1.1, we lay the groundwork by examining this fundamental shift. For years, AI has primarily functioned as a reactive system, waiting for your input, executing a task, and then stopping. Think of it like a flashlight. It illuminates only when you press the button. But what if that flashlight could anticipate your need for the light? Perhaps by sensing a dark room and then turning itself on. That's the essence of agentic AI. It's about system that can perceive, reason, and act autonomously within an environment to achieve a goal, rather than just waiting for instructions. This isn't just a minor upgrade. It's a paradigm shift that promises to redefine our interaction with technology, making AI an active, collaborative partner rather than a mere utility. We'll uncover the core concept that differentiate agentic AI from its predecessors and set the stage for understanding how these intelligent systems are designed and deployed. Get ready to awaken your understanding of what AI can truly become. Let's bridge the gap between traditional reactive system and the exciting world of proactive agentic AI. Imagine your smartphone GPS, a technology many of us rely on daily. Historically, it's a perfect example of a reactive tool. You input a destination and it gives you directions. If you miss a turn, it patiently waits for you to notice and then recalculates. It doesn't anticipate your mistakes or proactively suggest alternatives until specifically prompted. It's a fantastic tool, but it operates solely on input and immediate output. Now, let's fast forward to a more agentic version of that GPS. Imagine it not only knows your destination but also understands your calendar, your typical routes, and even real time traffic patterns. As you are driving, it detects unexpected congestion ahead. Instead of waiting for you to get stuck and then reroute, it proactively suggests an alternative path, perhaps knowing you have an important meeting and need to arrive on time. It acts as a collaborative teammate, anticipate your needs, and taking initiative without explicit instruction. This proactive behavior, fueled by an understanding of intent and context, is the hallmark of agentic systems. We are moving beyond simple cause and effect to a future where our AI partners anticipate, adapt, and collaborate seamlessly. Now, let's define the suspect by profiling the key differences between traditional AI and agentic AI. For a long time, most machine learning models behaved much like a calculator. You feed in some numbers, it performs a calculation, gives you an answer, and then it's done. This is what we call traditional AI, the tool. It's excellent for specific, well defined tasks. You input data, it outputs a result, and that's the end of its involvement. It has no memory or understanding of continuity between operations. Each interaction is a fresh start. Think of it as a single use function: input, process, output, stop. There is no context carried forward, no learning from past interaction. However, agentic AI or the teammate operates on a fundamentally different principle. An AI agent behaves like a genuine colleague. It doesn't just process individual requests, it interprets overarching goals, prioritizes tasks based on those particular goals, and critically, it adapts when conditions change. It's not a one shot operation, it's a continuous loop of interaction and learning. This is powered by its ability to maintain context over time, understand the environment, and reason about its next step, much like a human teammate would. This continuous loop and contextual awareness are what transforms a passive tool into an active, intelligent collaborator. To truly understand the shift, Let's put these two types of AI in a lineup and identify their key differences. On one side, we have a traditional AI system, which we have characterized as stateless. Imagine person standing against a height chart holding a stateless sign. Traditional AI is fundamentally passive. It simply waits for input. It has no memory or state between calls. Each interaction is independent, meaning it doesn't remember previous queries or context. Its goals are fixed, often for tasks like classification or prediction, and is designed for a one shot task where you provide all the necessary information upfront. It executes and then resets. Now, on the other side, we have an agentic AI system holding a stateful sign. This is where things get truly interesting and exciting. Agentic AI is active, it takes initiative. Crucially, it is stateful, meaning it maintains context over time. It remembers past interaction, learned information, and ongoing goals. Its goals are adaptive. It can learn, reason autonomously, and adjust its objective based on new information or environmental changes. This adaptive nature allows for a continuous interaction loop where the agent constantly perceives, processes, and acts within its own environment, evolving its understanding and behavior over the course of time. These fundamental distinctions highlight why agentic AI represents such a significant leap forward in intelligent system. Let's delve in let's delve into the modus operandi of agentic AI. The sense think act loop. This continuous feedback loop is the fundamental architecture that enables an agent to operate autonomously and intelligently within its environment. It begins with perceive. Like any biological organism, an AI agent must gather information from its surroundings. This could involve reading sensor data, processing text, analyzing images, or receiving direct user input. The perception phase updates the agent's internal understanding of the environment, creating a rich, up to date model of the world it operates in. Once perceived, the information moves to the deliberate phase. This is agent thinking process. Here it reasons about the perceived information, evaluates its current goals, plans its next steps, and determines the most appropriate course of action. This involves complex cognitive functions, often powered by large language model to derive meaning and strategize. Finally, the agent moves to act. This is where it executes its plan, modifying the environment in some or the other way. An action could be sending a message, calling an API, controlling a robotic arm, or generating a response. This action, in turn, changes the state of the environment. The crucial part is the feedback loop. The environment changes, which then triggers the agent to perceive new information, and then it updates its understanding. It deliberates again on the new state and act again. This continuous sense think act cycle allows the agent to constantly adapt, learn, and achieve its goal dynamically, making it a truly proactive and intelligent system. Our first piece of evidence A, highlights autonomy as a cornerstone of agentic AI. The definition is straightforward. An agent decides what to do next without explicit human input for every single step. This is a radical departure from traditional system. The pain point with traditional machine learning models is that the dependency on external orchestration, essentially requiring a driver for every decision. Imagine a puppet. Every movement, every action needs a puppeteer pulling the string. This makes traditional AI incredibly powerful for very specific tasks, but it's inherently reactive and limited by the pace and input of its human operators. The solution offered by autonomy is profound. It frees the AI from this dependency. Instead of waiting for commands, the agent can initiate actions based on its internal goals and understanding of the environment. Think of a robotic vacuum cleaner as a perfect example. A traditional vacuum needs you to steer it, guiding its every move. But an autonomous robotic vacuum determines its own cleaning routes, avoids obstacles, and docks itself for charging, all without constant human supervision. It decides what to do next independently within the operational constraints. This ability to self direct and take initiative is what elevates an agent from a mere tool to a truly autonomous teammate. Our second piece of evidence B, focuses on perception, the eyes and ears of an agentic AI. Just like biological organism, agents must gather information about the world around them to function effectively. Without understanding its environment, an agent cannot make informed decisions or take appropriate actions. The mechanism through which this perception is achieved is diverse and constantly evolving. This can involve sensors such as cameras or microphones, APIs that provide access to vast amounts of digital data, or direct user input that provide explicit context and instructions. Essentially, anything that feeds information into the agent contributes to its perception. This flow of data, often represented in a stream of binary code, is translated into a meaningful internal representation. The necessity of perception cannot be overstated. Without it, autonomy would operate blindly. An agent wouldn't know if its actions were successful, if the environment had changed, or if new opportunities or challenges had emerged. By constantly perceiving, the agent forms and updates an internal model of its world, allowing it to act effectively, adapt to change, and make truly intelligent choices. Perception is the critical first step in the sense think act loop, enabling the agent to engage with its environment in a meaningful way. Let's move to evidence C, deliberation, which represents the mind of an agentic AI. This is the core engine of reasoning, goal evaluation, and planning. After an agent perceives information from its environment, it needs to process that data, understand its implication, and decide on the best course of action. This is where deliberation comes in. The technology behind modern agents, deliberate core often relies on large language models or LLMs. These powerful models can process complex information, understand the context, and generate coherent responses or plans. They allow the agent to think by simulating human like reasoning processes. The primary function of deliberation is to transform raw perception into contextual understanding. It's not just about seeing data, it's about interpreting that data in the light of agent's goals and the broader situation. For example, consider a calendar agent. If your user just postponed a meeting, the agent perceives that change. Through deliberation, it reasons. A postponed meeting changes travel timing. Therefore, I need to update the car service. This isn't just a simple if then rule. It involves understanding the implication of an event across different domains and planning a sequence of actions. Deliberation is where the agent connects perception with action, ensuring its responses are not just reactive but intelligent and goal oriented. Finally, we arrive at evidence D, action, the ultimate output of the agentic AI. This is where the agent reshapes reality. Actions are the means by which agents directly influence their environment, translating their perception and deliberation into tangible changes. This is the crucial stage where the internal thinking of the AI impacts the external world around it. The methods an agent uses for action are incredibly diverse. This can involve sending messages such as emails or chat notification, calling APIs to interact with the software system, triggering system events to initiate processes, or even moving physical actuators if the agent is embedded in a robotic arm. The key shift here is profound. The output of an agent isn't merely a prediction, a sentence, or a piece of data. While it might generate those things, the true action is a change in the state of the world. For instance, an agent might decide to book a flight. The action isn't just generating the booking confirmation text, but actually interacting with the airline system to reserve the seat. This distinction highlights the proactive and impactful nature of the agentic system. They don't just provide information, they make things happen, actively shaping and interacting with the environment to achieve their objectives. Let's take a quick look at the case history, evolution of the agent to understand how we have arrived at Agentic AI. Our journey begins with GOFAI, a good old fashioned AI, prevalent from the 1960s to the 1980s. This era focused on symbolic reasoning and logic rules, building AI system based on explicit knowledge representations. GOFAI was powerful in its domain, but it was brittle. If a sensor failed or a rule was incomplete, the entire logic system could break down. Think of it as a meticulously crafted machine with many interconnected gears. If one gear grounds to halt, the whole machine stops. Next, we entered the ML era in the 2010s, dominated by deep learning. This period saw remarkable advancement in mastering perception, particularly in areas like vision and speech recognition. Machine learning model became incredibly adept at identifying patterns in vast datasets. However, while they could see and hear with unprecedented accuracy, they largely lacked planning capability and ability to reason without complex multi step goals. They were excellent at pattern matching, but not at proactive problem solving. This brings us to Agentic AI in the 2020s. This new paradigm combines the strength of both previous eras. It integrates the logical reasoning of GOFAI with the pattern recognition flexibility of ML, all interwoven through the power of large language models. This synthesis creates system that can not only perceive and recognize pattern but also reason, plan, and adapt autonomously. As the slide says here, every revolution starts with a limitation. Agentic AI is the synthesis, overcoming the brittleness of GOFAI and the planning limitation of the early ML to usher in a new era of intelligent system. So, what's the verdict on Agentic AI? The core takeaway is this: an AI agent is not just a model, it's much more than a sophisticated algorithm or a predictive engine. It is an active participant in the dynamic environment. Unlike traditional AI, which primarily serves as a tool for analysis or prediction, an agent takes initiative, adapts, and influences its surroundings. This distinction is crucial. Traditional AI makes decisions, often presenting options or insights for human user to act upon. Agentic AI, on the other hand, make things happen. It translates its understanding and plans directly into actions that modify the state of the world, whether that's scheduling a meeting, optimizing a logistic route, or controlling a robotic system. This active participation fundamentally changes our relationship with AI, moving from command and response to collaboration and co-creation. As we conclude this foundational topic, understand that this awakening of agentic AI open up immense possibility. We'll dive deeper next into the architectural details, specifically architecting the Sense Plan Act pipeline, to see how these intelligent agents are constructed to truly make things happen. Thanks for joining me for this introductory journey into the agentic system. If you like this video, please do like, share, and subscribe. Thank you.